Hey everybody, we continue to solve trig equations. So here I've got a trig equation for sine squared t minus 1 is equal to 0. And we want to solve this for values of t between negative pi over 2 and pi over 2. Okay, so this is one of those ones where this equation is fairly simple, but it can look confusing because especially if the trig functions are new to us, it just kind of makes things look a little less familiar than they actually are. So I might do something like this to simplify things. I might make a notational change, right? Remember, I'm trying to solve this equation for t. Right now, t is inside the sine function. So really my first job is to solve for that sine function. And then once I've solved for the sine function, then I'll worry about getting the t. So with that in mind, it might make sense to use a little notational trick. Just simplify this set of symbols. Sine of t, instead of all those little squiggly marks, make a simple set of 3 straight lines to represent it. So I'm letting that symbol a, represent sine of t, right? Just for the moment while I solve this. So then I can rewrite this equation as 4a squared minus 1 equals 0. Okay, right. You don't have to do this. It's not absolutely necessary. And when you get used to looking at these, you might find it superfluous, but it's certainly a good thing to do if you're having trouble looking at them and kind of understanding what to do, because this is a much more familiar kind of equation, right? We could factor this. Yeah, let's factor it. I think the most familiar way to do it would be to add 1 to both sides and divide by 4. But let's notice that this is also a difference of squares. So I could rewrite this as 2a minus 1, 2a plus 1 is equal to 0. This is only true if 2a minus 1 is equal to 0 or 2a plus 1 is equal to 0, which gives me, you can solve this to get a is equal to 1/2 or a is equal to negative 1/2. Okay, so we get 2 solutions like we often get when we have a quadratic equation. This is a quadratic equation here that we're solving, except we now have to go back to the substitution we made, the notational substitution we made, and realize this means that our equation is true if sine of t is equal to 1/2 or sine of t is equal to negative 1/2. Okay, now these can be simply solved by taking inverse sine, because remember, inverse sine only gives us answers in precisely the range that the question is asking us for. So when I write, if I take the inverse sine right? Remember, there's this little confusion about inverses when we, for the trig functions, we're not actually taking the inverse of sine as a function because the sine doesn't have an inverse. It's not 1-to-1. There are many answers for each input to sine, or many inputs for each output to sine. However, what this question really answers for us is what angle t, right? This side is going to give us an angle t whose sine is 1/2 and happens to be between these 2 values. So in this case, it's the perfect thing to do. We don't have to do any extra figuring. So t equals pi over 2. We can do the same thing here. Sorry, that's not the answer to that. I just copied what was written up there. So the sine between negative pi over 2 and pi over 2 that has the angle between negative pi over 2 and pi over 2 that has a sine of positive 1/2 is going to be pi over 6. And then we do the same thing here. Sine inverse of sine of t is sine inverse of negative 1/2. So in this case, t is equal to negative pi over 6, right? So these are the answers that a calculator will give. And in this case, they're correct. But it's still good to revisit our unit circles. So in the case where the inverse trig function doesn't quite give us the right answer, we just make sure we understand the geometry of the situation. So here's here's the situation, remember. What we just found here according to the inverse sine, what we just discovered here is that when we have an angle of pi over 6, we might know the x-coordinate, we might remember our unit circle, we might not. It doesn't really matter right now because all I cared about was the y-coordinate because we're looking at sine. This is telling me that the angle pi over 6, the intersection point or the value of sine of pi over 6 is 1/2. And then there's a reflection over the x-axis that has -1/2 as its y value, right? And those are the two answers we just got. Okay, so we have to understand that this is what inverse sine does. So for instance, if the answer had asked us to have, or if the question had asked us to produce an answer with values between, let's say, pi over 2 and 3 pi over 2, so I'm changing the question now just for an example, we would be looking on the other half of the circle, right? We would want to know and be able to say, okay, inverse sine gave me this answer over here, but actually, I'm more interested, right, over here is the angle. So this angle here, it's almost going a half rotation of pi. It's short by this amount here. Well, this amount here will be the same as this original angle, right? We're reflecting that line over the y-axis. So this amount here would be pi over 6. So being short a half rotation of pi by pi over 6 means this angle must be an angle of pi over 6. And we can see clearly on this picture that it's going to have the same y-coordinate, which again is all I care about right now. That's why I'm leaving the x-coordinates blank. And in a similar way, there's an angle down here. This one's 7 pi over 6. It's an angle of pi over 6 past the halfway mark, and this will have -1/2, right? So we see these two answers. If we were looking for 5 pi over 6 and 7 pi over 6 would be the answers if we were looking in this region. Let's do one other version of this question. Let's find all solutions to the equation, meaning no range is given, right? There's no set of angles, and there's no portion of the unit circle we want to look on. We want to look across all the possible solutions. Then we get back to that thing we've talked about previously where we sort of think we have to think about the geometry of the circle, pick like a base angle is what I often call it, my primary angle, and then think about rotations to get all the other angles, right? So these first two answers are pretty good ones. These are pretty good base solutions to this. But let's look at the circle I just created here. So here's let's get another color going up here just to make things more confusing. Here is, maybe that's not different again. Let's try a darker blue. All right, so here's my angle of pi over 6, right? It's a solution to this equation. And from this drawing, I see that if I rotate it by an angle of pi, I get another solution. And if I rotated another angle of pi, I'm getting another solution. And every time I rotate by an angle of pi, I'm getting the new solutions. And then of course I could reverse all these arrows. So in this case, because of the fact that remember we've done this before and we've ended up with things like plus 2 pi k because we're talking about full rotations. Now I only need pi k. Same thing with the negative pi over 6. You can see it's got this angle, a half rotation around it, plus pi k, where k is an integer. K is an integer. And the reason in this case we don't have to do that, again, the big reason is I just want to capture this as geometry of the situation. And I'm saying it that way because there are so many different kinds of situations that coming up with a set of rules for each and every one of them really isn't profitable because or efficient, because there's just so many situations you'd be memorizing a huge list of rules. What's most important is to be able to look at the circle and understand what's going on. In this case, what really happened is we had a quadratic. And so we ended up with two answers before we even solved for the variable inside our sine functions. There were two possible outputs to the sine function. And then we got possible inputs to the sine function from the trigonometry of the situation. So we have this, like, there's this extra multitude of answers, right? And what that meant is we didn't have to do full rotations anymore, because there were these extra answers from the quadratic part of the equation, I guess is one way to say that, right? And you can already see how confusing it is to try to explain why this is happening, right? There's a lot of things. There's a quadratic thing happening that gives us two answers, and then those two answers, when we explain them geometrically, we start to see what's fully going on here, and so we just need these rotations by pi, half rotations, for the full answers. Okay, I think that's enough for this one. There are some more to come, more trig equations coming, but that'll be it for now. Thanks, everybody. I will see you next time.